Okay, we're going to use the real numbers review. And remember, the numbers that we're looking at right now are all real numbers. And your circle, we should have rational, integer, whole, and natural. Okay, and over here is irrational. Okay, so remember, natural numbers start with 1. Okay, and they keep on going up. Whole numbers are just like the natural numbers, but they also include 0. Integers, positive and negative. Rational are all your natural, your whole, your integer, and we can say anything that can be written into a fraction, a over b, and b cannot be 0. Don't forget numbers like 3.3 with a bar over it, because we know exactly what the next number is. Because of that, we can make it into a fraction that would equal 3 3/9, okay, or 1/3. Also numbers like 2.4. It just terminated, right? And that one also can be made into a fraction, 2 4/10, and we can simplify that. So be careful when you're trying to classify them. Make sure you simplify it first. So if it's a fraction, you know it's going to be a rational number, but just see if you can simplify it to see if it fits in the other categories. And don't forget irrational numbers. We had pi, non-perfect squares. So if it's not a perfect square, automatically goes over here. Okay, and then the decimal one would be one that's just, oops, let's see, 1.2368, and we don't know what that next number is, so it goes there. And the reason for that is I cannot make that into a fraction because I don't know what the next number is going to be. Okay, so the problem number 2, it says irrational. So let's go back over here. All right, letter A is the square root of 77. Well, it's a non-perfect square. So letter A is irrational, non-perfect square. Oops, can't spell. Okay, letter B, 8 over 7. That's a fraction. So we're going to say A is. 8 over 7 is a fraction. That means it's a rational number. That's a rational number. So that's not a choice. All right, letter C. Well, that one terminates, right? And I can also write that as a fraction. So that's rational. So we're not going to circle that one either. I'm sorry. And letter D, 13.4568. We don't know what that next number is, so we cannot make it into a fraction. So it's irrational. Okay. All right, we are on number 3. Number 3, 18. Let's go back to this one right here. 18 is a natural number, right? Because you can count that one. If it's a natural number, it's a whole number. If it's a whole number, it's an integer. If it's an integer, it's rational, and it's also real. Okay? So number 3, we should have chosen real, rational, integer. That's why I keep on saying draw that Venn diagram. Whole and natural. Okay? All right, the next one, it didn't have a number on it, but it was that really weird one. It says there is no, there should have been a little line there, but it really didn't have one. So I left it like it was, and the table that you had to choose from was underneath, and it makes sense because there's no irrational numbers within the set of rational numbers. Now we're on number 4. Number 4, they gave you like 4 examples that you could use, and if you use those examples would help you solve this answer. So it's saying the sum or product. So sum is to add, and product is to multiply. So they're saying when I take let's look at the sum one first. When I take two rational numbers and I add them together like A and B, I should get a rational number. Well, we do. And the next part of that says when we take a product and we have two rational numbers, which is C and D, we will get a rational number. So the answer is rational. So number 4, I'm sorry. Number 4, you should have picked rational. All right, number 5, it's saying the sum of a rational number and an irrational number is, well, which one is it? So they're saying when we take 3 and we add it to pi, we get an irrational number. So letter B, when we take the square root of 29, which is irrational, and we add it to an integer or a rational number, it's -7, we still get irrational. And we try letter C, same thing. So the answer for number 5 is irrational. And let's look at number 6. Okay, so now the directions say for number 6, write each number in the subsets of which it belongs. Make sure to place each number in all correct subsets. So this is not like that Venn diagram. The Venn diagram is like when you start at the center, so say natural. If it's natural, it's also whole, then it's an integer, it's rational, so it's like a ladder step that you go up and up and up. Well, this is a chart. It's a different way. So now you're going to say, like example, 12/4, that equals 3. So I know it's a fraction, so I know it's going to go in rational no matter what, because it's a fraction. But I'm going to simplify that fraction, and that fraction equals 3. So it's a natural number, it's also a whole number, and it's an integer. Okay? So maybe we should put it in its original form here. Oops. So let's do 12/4. 12/4, because we know it equals 3, but we're just checking. Okay, so now we're going to look at, oh, I skipped pi, so let's go back to pi. Let's look at pi. Pi, it's irrational, so it goes here. And square root of 48. Well, is the square root of 48 a perfect square? That's the question. No. So it goes here. If it were a perfect square, then I'd simplify it and see what it was. All right, I've done 12/4, but not 4/12. Well, 4/12 is a fraction, so it automatically goes over here into rational numbers. And if I simplify it, I get 1/3, which, remember, natural numbers have those counting numbers. Then whole has a 0 in the counting numbers. Integers are positive and negative. There's no decimals, and there's no fractions in there, so it's only rational. So we did 12/4. Well, 0 is not natural, but it is whole, and if it's whole, it's an integer, and it's also rational. The 3.275, and it keeps on going. I don't know what that next number is. That goes here. Okay, 5.39. It terminates. I can make it into a fraction, so I know it's rational. I know it's just going to terminate and it stops. Okay, -95. Natural numbers don't have negatives in them. Whole numbers don't have negatives, but integers do, and if it's an integer, it's also rational. All right, the next number, -8/4. Ooh, that's a fraction. So that goes over here for sure in rational. And now let's check and see if we can simplify it. Well, 8 divided by 4, or -8 divided by 4, gives me -2. Natural numbers don't have negatives. Wholes don't have negatives. But integers are. Okay. And let's see. Negative square root of 49. Well, 49 is a perfect square. So when I do the square root of 49, it gives me 7. And I've got a -7. So when I know that's a perfect square, I know it's not irrational. It's got to be rational. Let's move this up. This line is getting really long, isn't it? And when I simplify it, I get -7. Natural numbers do not have negatives. Whole numbers do not have negatives. So integers do, though. All right, and 7.5%. Well, I can change that to a decimal, 1, 2. So I have 0.075 or 0.75, which means I can write that into a fraction. And if I can write into a fraction, it is definitely rational. Okay? Since it's a decimal, it's not a whole number, it's not an integer, it's not natural. And we're looking at 10 over 4. 10 over 4 is a fraction, so it automatically goes over here into rational numbers. Running out of space, aren't I? And if I reduce that, I get, or if I try to figure it out to see if it can be divided by evenly, no, it'd be 2 gives me 8 and 2/4. So that is a mixed number, so it's only rational, okay? Because whole numbers don't have fractions, natural numbers don't, and neither does integers. So 7/9, fraction, automatically goes over here. But there are no fractions in the integers, it can't divide into a whole number, and it's not natural. And then we're going to look at -6.3. This decimal means I can make it into a fraction. And I know it goes over here. Another way to look at it is it's a terminating decimal. Okay, like we learned in class. Okay, I hope that has helped.